Good morning, everybody. In pre-calculus, I've been getting a lot of questions about how to find explicit functions, and we're going to do a real quick example today to show you how to solve simultaneous equations, because I don't think you're having trouble recognizing the type of function. I think you guys don't know how to find the coefficient. So let's take a look at this example right here. You've been given a table, and you're asked to find out what kind of function it is and what is the explicit function. Well, you guys know what you got to do. You got to find out if you've got evenly spaced input intervals, and we do, so we know we're in business. So coming over here, we're looking to find out what the differences are for the outputs. But the first difference is not going to be a constant. This is going to require us to go to maybe a second or even a third difference. So let's see what happens. When we do that, what we find out is the first difference right away on the inputs is 2. The second difference on the outputs is a constant 8. So what does that tell us? Well, you know exactly what that tells us. It tells us that we've got a quadratic function because over equally spaced input intervals, the change in the average rate of change is constant. Again, that's the change in the change, that second difference. What do we know? We know this is ax squared plus bx plus c. You could go to polynomial notation, say a sub 2x squared plus a sub 1x plus a sub 0. But if we got enough letters in the alphabet, we'll use the alphabet. We got ax squared plus bx plus c. Your job now to find a, b, and c. How do you do it? Well, you've got three unknowns, a, b, and c. And if you've got three unknowns, that means you need three equations. Where are you going to get those equations from? You're going to find yourself 3 points. And lucky for you, you've got a whole bunch of points here to use. So let's see what we're going to do. My suggestion to you is to find your 3 points, get your three unknowns. What I'm going to do is I'm going to use the three inputs that are the smallest, the easiest to work with. I'm going to work with 1, 3, and 5. A lot of you are trying to find other inputs. You want that 0 input. Yeah, there's an advantage to using 0, but it's not always easy to find the 0 input. So just, don't be afraid. Use the inputs they give you, 1, 3, and 5. So what am I going to do? This says if I plug in 1, I'm going to get out 4. If I plug in 3, I'll get out 8. If I plug in 5, I'll get out 20. I do exactly that, okay? I'm going to plug in 1 into this equation right here. What is that going to give me? That's going to give me A plus B plus C, and it's going to have to give me 4, okay? So that's what I know. Plug in 1, get out 4. I'm going to plug 3 into this equation right here. That's going to make this guy right here 9. That's why I've got a 9A. It's going to make this guy 3, so that's why I've got a 3B. And it's going to make this guy right here C, because he's a constant. And that's going to equal 8 when we plug in 3. And then I'm going to plug in 5, and that's going to make my x squared 25. So you see a 25a there. Going to make that x at 5, so you see a 5b. It's not going to touch that c, so you got a c, and the output's going to be 20. Now I've got three equations. I've got three unknowns. I'm in business. Let's go solve these equations simultaneously. So we'll copy these guys right here, and we'll bring them down here. And here's the idea. When you've got three unknowns, three equations, you're going to want to do it. You're going to want to do an elimination. I'm sorry, a substitution method. So what we're going to do is we're going to take that bottom one, and we're going to solve it for c. And when we do that, we're going to get c equals 20 minus 25a minus 5b. Now that we know what c is, we're going to plug equation 3, let's call that equation 3, into equations 1 and 2. So when I take equation 1, I'm going to rewrite that, but this time I'm going to get rid of that c, because c is equal to this, 20 minus 25a plus b. I'm going to do the exact same thing in equation 2. I'm going to take equation 3, I'm going to plug it into the other two equations. It's always important we plug it into the other two equations. So we're getting rid of that c, and we're replacing it with 20 minus 25a minus 5b. So now we've taken equation 1 and substituted in equation 3. We've taken equation 2 and substituted in equation 3. And what has that done for us? It's gotten rid of one of the unknowns. We've gone from three equations, three unknowns, to two equations, two unknowns, and we're much, much, much more comfortable in that situation. So let's go combine like terms, okay? We're going to get negative 24a right there. Negative 24a when we combine these two guys. Let's go get those b's. We got negative 4b. And now let's bring this 20 to the other side by subtracting it. That's going to give us negative 16. I'm going to go and I'm going to divide everything here by negative 4 just to make it simpler. So, okay, so we can take this equation, divide both sides by negative 4. We're going to get 6a plus b equals 4. Okay, that's going to be important. That's one of our two equations with two unknowns. Let's go over the other equations, do the same thing. Let's combine like terms. We got a 9a and a negative 25a. That's going to give us what? Negative 16a. We got a 3b and a negative 5b. That's going to give us negative 2b. We're going to bring this 20 to the other side, and that's going to give us a negative 12. On this side, I'm going to divide everything by negative 4, and that's going to give us 4. I'm sorry, no, negative 4 is not going to be so great. Let's do negative 2. That's going to give us 8a plus b equals 6. So now we've got these two equations. So let's treat this like a system of two equations, two unknowns. Let's take this guy. Let's put it right here. Let's solve it together with this guy. Let's stack them. And now I can use elimination or substitution. Elimination is looking really good here. What I'm going to do is I'm going to subtract the bottom equation from the top. When I do that, I'm going to get 8a minus 6a. That's going to give me 2a. Those b's are going to cancel, so we're going to lose those b's. And then we're going to do 6 minus 4, and that's going to get me 2. That tells me that a is equal to 1. Okay, we want that piece of information. Now from there, you can go to any equation you want. I like these guys right here because they've only got a's and b's in them, and I know what a is now. So if I take this guy and I bring it up here, what do I find out? I find out that 8 times 1 plus b equals 6. And again, I'm just bringing that up here. That tells me that 8 plus b equals 6. That tells me that b is equal to negative 2. So now I've got A, now I've got B. Now I got to dig back further, find an equation with C in it. And look at this guy. A plus B plus C equals 4. So let's grab that guy right there. Let's bring him down, and let's use our two new facts. Let's use that A is 1. Let's use that B is negative 2. And what do we end up with? We end up with 1 plus negative 2 plus C equals 4. That's negative 1 plus C equals 4. That tells us that C is equal to 5. What does that tell us? Well, we started this by saying that f of x was equal to ax squared plus bx plus c. We now know that a is 1, that b is negative 2, and that c is 5. So our final explicit equation is x squared minus 2x plus 5. Now, you don't have to believe me. You don't have to take me at my word, because here's the beauty of math. You can always check your answers. A lot of you guys wait and want me to give you the answers. You can check it yourself. How do I do that, you're wondering? Well, let's copy this guy. Let's go all the way back, all the way back. Let's paste it right here. What happens if I plug 1 into this equation? Okay, I get 1 minus 2 plus 5. What does that equal? That equals 4. That's a check. What happens when I plug 3 into this equation? I get 9 minus 6 plus 5. And sure enough, that equals 8. That's a check. What happens when I plug 5 into this equation? I get 25 minus 10 plus 5. And what does that equal? Sure enough, it equals 20. So we know that this equation is correct, okay? So here's the deal. I don't think any of you guys are having trouble with this part. I think this part is very straightforward. I think I taught you that beautifully, and you guys understand this. We've got a common second difference, and that means we've got a quadratic. I think you guys are all getting mixed up because you have no idea how to solve systems of equations. And the way you solve a system of equation, again, the way you find it is you use any 3 points. I could have used any 3 points, okay? I didn't need to use 1, 3, and 5. I could have used any of them. But it doesn't matter which ones you use. In this situation, you end up with 3 equations, 3 unknowns. Take one equation, solve it for C, substitute that into the other 2. That's now going to give you 2 equations with 2 unknowns, and now you should be on easy street. Now you should be all set, because elimination or substitution will work. Go back, plug in, get your answer, okay? Be sure to check it at the end. You can always make sure you've got it right. I've been gone for a little while. I'm planning on coming back hopefully pretty soon. But until I do, I told you I'd make videos for every time you guys have lots of questions. So I had a lot of questions on this particular example. I made a video. If you have any questions at all, feel free to reach out to me now. Please watch the video first and then let me know how you're doing. Hope everyone's doing great, and I hope to be back soon. Take care, everybody. See you soon.